And to describe that discovery, I'd like to hand it over to John Jenkins from the NASA Ames Research Center, the lead author on the paper.
Well, thank you, John. And welcome to all of you who joined us to hear this latest chapter in the unfolding story of NASA's search for habitable worlds. In the 6 years since we launched Kepler, we've made amazing progress in the search for the right-sized planet in the right-size orbit of the right-sized star. We're looking for small planets in the habitable zone of their stars, that region within which liquid water could pool on the surface of a rocky planet like Earth. In December 2011, with just 2.5 years of data under our belts, we announced the discovery of Kepler 20e, the first planet smaller than Earth orbiting a sun-like star. But it's so close to its star that it's scorching hot and cannot hope to hold on to an atmosphere, let alone a liquid water ocean. But in that same month, we announced the discovery of Kepler 22b, the first planet in the habitable zone of a sun-like star. But with a radius of more than twice that of Earth, it's highly unlikely to have a solid surface you or I could walk on. So the search went on. We collected more data. Just over a year ago, we announced the discovery of Kepler 186f, the first near-Earth-sized planet in the habitable zone of a small, cool M star, about half the size and mass of our Sun. Well, today, we're pleased to announce the discovery of Kepler 452b, the first small planet in the habitable zone of a G-type star very similar to our own Sun. So to introduce you to this planet, I'd like to show you an artist's concept shown in Figure 4. Looking at this image, I'm reminded of a poem by John Keats on first looking into Chapman's Homer. Then felt I like some watcher of the skies when a new planet swims into its ken. Now this illustration draws upon the facts that we do know about this planet and its star. The star is the same surface temperature and type as the Sun, a G2 star. The star is 10% bigger and 20% brighter than our Sun, as it's somewhat older. And this planet orbits its star every 385 days, and is just 5% farther from its star than the Earth. Now, with a radius 60% larger than Earth, this planet has a somewhat better than even chance of being rocky. To come up with this illustration, we consulted with planetary geologists and atmospheric scientists studying exoplanets to determine what this planet would be like if indeed it is rocky. It would likely have a mass about 5 times that of Earth and a surface gravity about twice that of Earth. So you and I would weigh twice as much as we do now, but only until we walked around for a few weeks and lost some serious pounds. We'd also expect the atmosphere to be thicker and have more cloud cover, and this planet would likely still have very active volcanoes. To put this discovery into context, let's look at Figure 5, which shows the Kepler 452 system alongside that of Kepler 186 and the solar system. The green shaded regions indicate the habitable zone in each system. Now, as you can see on this figure, Kepler 186 is clearly a miniature solar system. The orbits of all 5 planets, including the outermost, 186f, would fit inside the orbit of Mercury, which, as we all know, is not a habitable world. In contrast, the habitable zone of Kepler 452 is nearly the same size and extent as that of our Sun. Moreover, the size of the orbit of 452b is nearly the same as Earth. So to put this discovery in context with all the small confirmed planets less than 2 Earth radii in the habitable zone that we've discovered by Kepler in the last 6 years, I'm showing a scatter plot of all these planets on Figure 6, in terms of the surface temperature of the star they orbit on the y-axis, and in terms of the amount of energy received from their star in Earth units on the x-axis. The light and dark green shaded regions indicate the conservative and optimistic habitable zones, respectively. The blue disks indicate the sizes of these planets relative to one another and to the Earth, depicted here alongside Venus and Mars in the upper part of the diagram. Note that all the planets discovered before today lie in the bottom half of the diagram. That is, they all orbit stars that are significantly cooler and smaller than the Sun. Well, today the Earth is a little less lonely because there's a new kid on the block who moved in just right next door in terms of the surface temperature of the star it orbits and the energy it receives from its star. Now today, 452b receives 10% more energy than the Earth does, but that wasn't always the case. Figure 7 presents a window into time depicting the history of the habitability of Kepler 452b and the Earth. Stars are like people. When they're young, they're small and dim. As they grow older, they fill out, slow down, and they get brighter. Here, we examine the change in the environment of Kepler 452b in terms of the energy it receives, in Earth units, on the y-axis, and in terms of the age of its star, in billions of years, on the x-axis. When this star was young, it was only about 80% of its present size and 64% as bright. So the planet receives 64% as much energy then. But as it aged, the star grew larger and brighter, as depicted in the inset, so that the planet experienced a steady increase in energy up to its present age of 6 billion years, where it's receiving 10% more energy than the Earth does. Now, it'll leave the habitable zone for good at an age of about 9 or 10 billion years as the star continues to grow. But it's very interesting to note that the Earth follows neatly in the footsteps of its older, bigger first cousin, and will receive the same amount of energy as 452b does today in another 1.5 billion years. Now, at this point, the Earth may begin to experience a runaway greenhouse effect, according to models that scientists have to predict what might happen, reducing the water inventory substantially. Kepler 452b, on the other hand, is protected by its higher mass from this event for another 500 million years or so. I'd like to focus for a moment on the present age of 452b as depicted in Figure 8. It's simply awe-inspiring to consider that this planet has spent 6 billion years in the habitable zone of its star, which is longer than the age of the Earth. That's considerable time and opportunity for life to rise somewhere on its surface or in its oceans, should all the necessary ingredients and conditions for life exist on this planet.